3.3 for us. They're a little bit, I picked them because they're a little bit unusual, or they introduced something that we didn't quite get to go over in class. So the first one is we're going to take the function, gotta get my draw going here. And there it is. Apologies while I get started here. Yeah, purple sounds good. Okay, so we're gonna start with a function f of x equals, yikes, x to, oh wow, negative, start that again, negative 4 x to the third power plus 6 x squared plus 12x plus 4. And what we are told is that we want to check, let me see, what does it say here? Yes, demonstrate that k equaling 1 minus the square root of 3 is a root. So prove that that is a root. And then what we'll do too is we will factor it the rest of the way when we're done, okay? So again, we can do this using synthetic division. Now, we didn't do the synthetic division in class with anything like square root of anything. So let's just kind of see what that looks like. So when we set up our synthetic division this time, I'm going to leave a little more space because we're going to have some bigger things happening here. All right, so we're going to have some wider numbers as we work through this, okay? Now, the other thing that you can do, just like when we did long division with the polynomials, is if you're not sure what the multiplications look like, you can do them off on the side so that you get the correct answers, okay? So first step is to bring down this first coefficient here. Then we're going to multiply this times this. Now, again, if you need to do that off on the side, go ahead and do it off on the side. Otherwise, go ahead and complete that and put it up here. So negative 4 times 1 is negative 4. Negative 4 times negative square root of 3 is positive 4 times the square root of 3. Then we add this up. All right, and notice 6 minus 4 is 2. The rest of it stays the same. Now this is where you might need some side action here. You're going to take this times this for that next round, okay? Now 4 times the square root of 3 times the square root of 3 is actually just 4 times 3. Of course, square root of 3 squared is 3. So negative 4 times 3 is negative 12. Okay, so we have 2 minus 12 is negative 10. And this is plus 2 square roots of 3. All right, so like I said, it gets a little wild, but we will see what happens here. All right, and then we got 2 plus 2 square root of 3. All right, again, multiply on the side if you need to, which I'm going to put it there just so I don't make a silly mistake. So 2 minus 2 square root of 3 plus 2 square root of 3. Oh, that's beautiful. Minus 2 times, and this will be a whole 3, which would be 6. So negative 4. Lovely, look at that. Okay, so we got our remainder of 0. We're good to go. This is a root, we proved that. Now, you might wonder what on earth is going on here. Yes, we could write this polynomial answer if we would like to. Here's a hot tip though, okay? Hot tip, where should I write that? Over here, maybe. Hot tip. If you have a root where you have 1 minus or plus a square root, remember that when you do the quadratic formula, these come in pairs. If the negative square root is a root, then the positive square root is as well, okay? And again, that's a shortcut that you can take. Let's just prove it to ourselves here. Let's make sure that 1 plus the square root of 3 also works here as we divide through. So what do we got there? Negative 4, and this would be minus 4 times the square root of 3. Okay, so notice that that goes away. We're left with negative 2. And then negative 2 times this is negative 2 minus 2 square root of 3. Boom, done. Okay, so what's left here? As we talked about in class, this is our remainder. This is our free term, and this is the one with the x on it. So this would be a factor of negative 4x minus 2. Okay. So the other way to, so that's a factor. So again, let's review what we know here. Oops, cubed. X squared plus 12x plus 4. Okay, so what we know is that that can be factored as x minus this guy times x minus this guy times negative 4x minus 2. So those are our three, that tells us our three roots. So 1 minus square root of 3 is one root, 1 plus the square root of 3 is another root, and this is our third key to finding the root. So if we're going to find roots, we set each of these equal to 0, right? And if this one is equal to 0, we get the x equals 1 minus square root of 3. This one equal to 0 gives us x equals 1 plus the square root of 3. Now this one's a little tougher to see, but we can set it equal to 0 and solve it. So we got, oops, that's a negative 4. So negative 1/2, okay? So we have three roots here. We have negative 1/2. We have 1 minus the square root of 3, and we have 1 plus the square root of 3. All right. So, and this hot tip, keep that in mind as you're working. It'll save you time later on, okay? All right, the other one I wanted to do was one where we have a little bit of complication after our first step. And so let's see what that looks like. Give me a new color here. I want, ooh, I don't know. Ooh, that's nice. Let's do that one. Okay, so we have f of x equals x cubed minus 12x squared plus 40x minus 24, and we are told that x equals 6 is one root, and we want to find the others and factor. All right, so we know that we can use x equals 6 to help us get started by using synthetic division. So we've got 1 is our first, 3, 2, 1, yep, we're good, okay. So just copy down these coefficients, none are missing, and 6 is our divisor, so going like that, 6 times that is that, minus 6, negative 36, 4, 24, boom. Okay, so yes, remainder of 0, that means x equals 6 is a root. When we divide by, so basically what we just did was divided this polynomial by x minus 6, and we get a remainder, or a quotient, sorry, of x squared minus 6x plus 4. Now, I would like to continue to factor that. So, looking at this, thinking, I can't think of anything that works. Okay, so let's go to the quadratic equation, all right? So minus b is minus negative 6 plus or minus the square root of b squared minus 4 times a, which is 1, boring, but okay, times c, which is 4, all over 2 times a. And again, a is just 1. So what are we at here? That's a positive 6 then out front. And this is what? 36 minus 16. So square root of 20 over 2. All right, now I happen to know that 20 has a perfect square in it. 20 is made of 4 times 5. Square root of 4 is 2. The 5 can stay in. Now, what that means is that we have 6 over 2 plus or minus, whoops, 2 times the square root of 5 over 2, which means we have 3 plus or minus, oh geez, I was thinking 5 when I wrote, that's a 2, plus or minus the square root of 5. Okay, so we have 3 plus the square root of 5 is one piece of that. 3 minus the square root of 5 is the other piece of that, okay? So our roots are 6 and 3 plus the square root of 5 and 3 minus the square root of 5, okay? So if we were going to write these in order, 3 minus the square root of 5 would be the smallest one. 3 plus the square root of 5, now the square root of 5 is a little more than 2, so we know that 3 plus the square root of 5 is a little smaller than 6, and those are our roots in order. So now if we're going to write these as factors, the way to do that is x minus each one. And times x minus 3 plus the square root of 5. Oops, ran out of doodle board there. Had to move my hand over. And x minus 6. That's how we would factor this polynomial. So if we wanted to multiply this all back out, we would get back to that polynomial we started with. Now if you want to, you can go one more step and distribute these negatives here. So that would be x minus 3 plus square root of 5, x minus 3 minus the square root of 5, and x minus 6 again. All right, so there's the factoring, which means that these are the roots of that polynomial. Okay, so if you get stuck and you get down to here and you know that you have, you're at a quadratic stage, you've got one factor or one root figured out, and you're at a quadratic stage, you can always turn to the quadratic formula to finish this if it's something that you can't factor or can't figure out how to factor. Right? So I wanted that to be an example that you had so that you could finish that process.